What if I told you there's a $500 billion wave of infrastructure projects underway right now across the United States? Projects so massive, so ambitious, they could reshape how we live, work, and move. Welcome to EngiArchis. Today, we're exploring America's $500 billion megaproject pipeline, what it is, who's building it, and why it matters. First, let's define what we mean by a megaproject. These are large-scale construction efforts, typically costing billions of dollars. They involve multiple stakeholders and often take years, sometimes decades, to complete. In the United States, there are currently more than $500 billion worth of megaprojects in progress. These projects aren't just bigger versions of normal builds. They bring extraordinary complexity, high risk, and massive public attention. The rise of megaprojects isn't random. It's driven by aging infrastructure, government stimulus, and the growing need for climate resilience. Urban expansion and population growth are pushing cities to evolve faster than ever before. In fact, a large portion of non-residential construction spending in the U.S. now goes toward megaprojects. But with size comes challenge. Budgets balloon, timelines slip, and risks multiply. The bigger the project, the harder it is to control. Let's look at some real examples. The Gateway program between New York and New Jersey, more than $16 billion just for tunnels and expansion. The California high-speed rail, projected to cost $135 billion and stretch over 750 miles of track. Massive energy and infrastructure complexes transforming the way power and data flow. Each project pushes the boundaries of engineering and planning, and each carries enormous economic and environmental implications. Megaprojects promise transformation, but they come with serious risks. Cost overruns, political battles, and environmental impacts are constant challenges. Studies show that most megaprojects exceed their original budgets by 20% to 50%. Some even double before completion. They become case studies of what happens when ambition meets reality. They're called mega, not just for their size, but for their complexity. When things go wrong, taxpayers pay the price. But when they succeed, they redefine what's possible. Behind every megaproject lies a story, a battle between vision and reality. Let's take a closer look at what makes these projects succeed or fail. The first critical factor is planning. Most megaprojects fail long before construction begins. Why? Because the planning phase is rushed, driven by politics instead of engineering. Deadlines are announced before designs are ready. Budgets are set before costs are known. And once construction begins, changing direction becomes almost impossible. One example is the California high-speed rail. It started as a dream, a train connecting San Francisco and Los Angeles in under 3 hours. But delays, lawsuits, and land acquisition challenges stretched the timeline for decades. What began as a $33 billion plan has ballooned to over $135 billion and counting. Still, it remains one of the most ambitious infrastructure visions in modern history. Another example, the Hudson Tunnel Project, part of the Gateway program. A pair of 100-year-old tunnels under the Hudson River still carry more than 200,000 passengers every day. Each morning, engineers hope they'll hold another day. Their replacement, delayed by years of political gridlock, is finally underway, one of the most expensive rail investments in the world. When completed, it could redefine rail travel across America's busiest corridor. Then there's the Brightline West, the new high-speed train linking Las Vegas and Los Angeles. Unlike many public projects, this one is privately funded. If it succeeds, it could prove that private investment is the missing key to solving America's infrastructure crisis. But how are all these megaprojects funded? That's where things get complicated. Traditional funding, taxes, and federal budgets is no longer enough. Today's megaprojects rely on a mix of public-private partnerships, infrastructure bonds, and global investors. The result? A new era where engineering meets finance and risk is shared between governments and corporations. These partnerships are changing the game. They bring speed, innovation, and accountability. But they also create new challenges. When profit meets public interest, priorities can clash. After all, should infrastructure be built for people or for profit? That's a question the U.S. will keep facing for decades to come. Beyond finance, there's a quiet revolution happening in construction technology. Digital twins, 3D modeling, and AI-driven project management are predicting risks before they happen. Robotics and automation help workers complete dangerous tasks faster and safer. And modular construction, where entire bridge sections or stations are built off-site, is cutting costs and timelines dramatically. In states like Texas, massive data centers and gigafactories are rising almost overnight. They represent not just industrial growth, but a redefinition of American infrastructure. The line between physical and digital construction is fading. Engineers now build worlds in both concrete and code. But perhaps the most important factor of all is sustainability. The climate crisis is forcing engineers to rethink everything. How do you build a city that survives hurricanes? A bridge that endures rising sea levels? Every megaproject now carries that moral and technical challenge. In Miami, entire districts are being elevated above sea level. In California, mega-scale solar farms stretch for miles, powering millions of homes. And across the Midwest, wind corridors are transforming America's heartland into an energy powerhouse. Each project isn't just construction, it's adaptation. In the end, these mega-projects reflect who we are. They show our desire to build, to innovate, to push beyond limits. But they also reveal our weaknesses: short-term thinking, political division, and lack of long-term vision. For every success story, there's a cautionary tale. For every bridge that connects, there's a tunnel that collapses. And for every dream of progress, there's a question of cost, not just in dollars, but in time, environment, and trust. America's $500 billion pipeline isn't just a list of projects. It's a test of engineering, of leadership, and of our ability to build a future worth living in. So, that's a look at America's megaproject pipeline, a world of ambition, engineering, risk, and reward. If you're fascinated by how the world is built and how it's about to change, what if I told you there is a $500 billion wave of infrastructure projects underway right now across the United States? Projects so massive, so ambitious, they could reshape how we live, work, and move. Welcome to EngiArchis. Today we're exploring America's $500 billion megaproject pipeline, what it is, who's building it, and why it matters to every single one of us. First, let's define what we even mean by a megaproject. These aren't just your average construction sites. We're talking about large-scale, complex ventures, typically costing billions of dollars. They involve a massive web of stakeholders and often take years, sometimes even decades, to complete. Right now, there are over $500 billion worth of these projects in progress across the United States. They're not just bigger versions of normal builds. They bring extraordinary complexity, high risk, and massive public attention. So why the sudden boom? This rise of megaprojects isn't random. It's a perfect storm driven by aging infrastructure desperately in need of an upgrade, government stimulus packages injecting cash into the economy, and the growing urgent need for climate resilience. Our cities are expanding, and populations are growing, pushing us to evolve faster than ever before. In fact, a huge portion of all non-residential construction spending in the U.S. now goes toward these colossal projects. But with great size comes great challenge. Budgets expand, timelines shift, and risks multiply. It turns out, the bigger the project, the harder it is to control. Let's look at some real-world examples to get a sense of the scale. Take the Gateway program, a critical link between New York and New Jersey. It's a more than $16 billion effort to build new tunnels and expand capacity. Then there's the California High-Speed Rail, a project with a projected cost that has soared to $135 billion, aiming to lay over 750 miles of track. We're also seeing massive energy and infrastructure complexes designed to transform how power and data flow across the continent. Each one of these projects pushes the boundaries of engineering and planning, and each carries enormous economic and environmental implications. Megaprojects promise transformation, but they come with a hefty dose of reality. Financial risks, political debates, and environmental concerns are constant companions on this journey. Studies have shown that most megaprojects don't just go a little over budget, they often exceed their original costs by 20 to 50%. Some even double before they're finally completed. They become fascinating and sometimes painful. Case studies of what happens when ambition meets reality. They're called mega not just for their size, but for their mind-boggling complexity. When things go wrong, it's often the taxpayers who foot the bill. But when they succeed, they redefine what's possible and set a new standard for the future. Behind every single megaproject lies a story, a delicate balance between a grand vision and the harsh realities of execution. So let's take a closer look at what makes these projects succeed or fail. The first critical factor, perhaps the most important one, is planning. You might be surprised to learn that most megaprojects face their biggest obstacles long before a single shovel hits the ground. Why? Because the planning phase is often rushed, driven more by political timelines than by sound engineering principles. Deadlines are announced before designs are even finalized. Budgets are set before costs are fully understood. And once construction begins, changing direction becomes almost impossible, like trying to turn a freight train on a dime. A classic example of this is the California high-speed rail. It started as a beautiful dream, a sleek modern train connecting San Francisco and Los Angeles in under 3 hours. But a storm of delays, legal battles, and challenges with land acquisition has stretched the timeline out for decades. What began as a $33 billion plan has ballooned to an estimated $135 billion and counting. Despite the struggles, it remains one of the most ambitious infrastructure visions in modern American history, a testament to the sheer will to build something transformative. Another critical project is the Hudson Tunnel, a key part of the Gateway program. Imagine this: a pair of 100-year-old tunnels under the Hudson River, damaged by Hurricane Sandy, still carrying more than 200,000 passengers every single day. Their replacement, delayed by years of political gridlock and funding disputes, is finally underway. When completed, this new tunnel won't just be a piece of infrastructure. It could redefine rail travel across America's busiest corridor, impacting millions of lives and the entire Northeast economy. Then there's an interesting outlier: Brightline West, the new high-speed train set to link Las Vegas and Southern California. What makes this project different? Unlike many public works, this one is privately funded. It's a massive gamble. If it succeeds, it could provide a powerful new model, proving that private investment might be the missing key to unlocking America's infrastructure potential and getting these massive projects built faster and more efficiently. But that brings us to the billion-dollar question. How are all of these megaprojects funded? This is where things get really complex. The traditional methods, relying on taxes and federal budgets, are no longer enough to cover these astronomical costs. Today's megaprojects are financed through a sophisticated cocktail of public-private partnerships, known as P3s, infrastructure bonds sold to investors, and even funding from global investment firms. This has created a new era where engineering meets high finance, and the risk is shared between governments and corporations. It's a high-stakes game, but it's the only way to get these monumental projects off the ground. So, we've seen the vision and the challenges. What does a successful megaproject actually look like? It's not just about finishing on time and on budget, though that's a huge achievement. True success is about delivering long-term value. A successful project integrates seamlessly into the community, boosts the economy, and improves quality of life for generations. Think of the Hoover Dam or the Golden Gate Bridge. They weren't just feats of engineering. They became symbols of human ingenuity and national pride. They created jobs, opened up new regions for development, and continue to serve millions of people decades later. That's the real benchmark. To achieve this, project leaders are adopting new strategies. Modular construction, where large components are built off-site in a controlled environment and then assembled on location, is helping to speed up timelines and improve quality. Advanced digital tools like Building Information Modeling, or BIM, create a virtual 3D model of the entire project. This allows teams to spot clashes and problems before they happen in the real world, saving immense amounts of time and money. Furthermore, a new emphasis on stakeholder engagement, bringing communities, environmental groups, and local governments into the planning process early on, is helping to build consensus and avoid the legal and political battles that have derailed so many projects in the past. Ultimately, America's $500 billion megaproject pipeline is more than just a collection of construction sites. It's a reflection of our nation's ambition, our challenges, and our hopes for the future. These projects are a massive bet on our ability to innovate, collaborate, and build a better tomorrow. They will test our engineering prowess, our political will, and our financial creativity. Have you ever wondered what it takes to build a city that can withstand a hurricane? Or a bridge that adapts to rising sea levels? America is in the middle of a construction boom unlike anything we've seen in generations. We're talking about megaprojects, massive undertakings that are reshaping our skylines and our future. But this isn't just about pouring concrete and raising steel beams. Something much bigger is happening. For decades, many of America's roads, bridges, and rails were stuck in a time warp. But now, a perfect storm of funding, technology, and global ambition is kicking things into high gear. It all starts with the money. We're seeing a flood of investment from both the public and private sectors. Think about the historic bipartisan infrastructure law. It's a game changer, injecting billions into modernizing everything from airports to our power grid. But here's where it gets interesting. It's not just government checks being written. Private companies are jumping in, forming powerful public-private partnerships, or P3s. These collaborations are changing the rules of the game. They bring speed, innovation, and a sharp focus on accountability. Projects that once took decades to plan can now get off the ground much faster. But these partnerships also raise some tough questions. When profit motives meet public interest, who really benefits? Should a new highway be designed to serve the community or to maximize toll revenue? This is the fundamental debate America will be grappling with for years to come. Are we building for people, or are we building for profit? It's a delicate balance, and the answer will define the character of our nation's infrastructure. Beyond the financial deals, there's a quiet revolution happening on the construction site itself. This is where the real magic is unfolding. Forget old blueprints and manual surveys. We're talking about digital twins, exact virtual replicas of massive projects that allow engineers to test and troubleshoot in the digital world before a single shovel hits the ground. Imagine using advanced 3D modeling and AI-driven project management to predict potential risks weeks or even months in advance. This isn't science fiction. It's happening right now. These tools are saving billions of dollars and preventing costly delays by spotting problems before they become catastrophes. And it's not just software. Robotics and automation are transforming the physical work. Drones are mapping vast construction sites with pinpoint accuracy. Automated machines are helping workers complete complex, dangerous tasks faster and with greater safety than ever before. This fusion of human skill and machine precision is the new standard. Then there's modular construction. Picture this. Entire sections of a bridge, a building, or a train station are built in a factory under perfect conditions, and then transported to the site for assembly. It's like building with giant high-tech Legos. This method is slashing construction timelines and dramatically cutting costs, making megaprojects more feasible than ever. You can see this transformation in action all over the country. In states like Texas, colossal data centers and gigafactories seem to sprout from the ground almost overnight. These aren't just factories. They represent a total redefinition of what American infrastructure is. The line between the physical world and the digital world is blurring. Today's engineers are architects of both concrete and code, building worlds that exist simultaneously in reality and online. But perhaps the most powerful driver behind this new era of construction is something that affects us all: sustainability. The climate crisis is no longer a distant threat. It's a present-day reality that is forcing us to rethink everything. We can't just build bigger, we have to build smarter and more resiliently. The questions facing engineers today are monumental. How do you design for the next century, not just the next election cycle? Every single mega project now carries this profound moral and technical weight. It's not just about building something that stands up. It's about building something that can stand the test of time and nature. Look at Miami. In a bold response to rising sea levels, entire districts are being physically elevated, a massive undertaking to protect the city's future. Travel west to California, and you'll see vast solar farms stretching for miles across the desert, generating clean power for millions of homes. And across the Midwest, a network of wind corridors is turning America's heartland into a global energy powerhouse. Each of these projects is more than just construction. It's a statement of adaptation. It's a sign that we're learning to work with our environment, not against it. We're building not just for today's needs, but for the challenges of tomorrow. So, what's the real force behind this new age of American megaprojects? It isn't just one thing. It's not just government funding or a growing population. It's a powerful combination of groundbreaking technology, fierce economic competition, and a renewed sense of global ambition. All around the world, nations are in a race. A race to build faster, smarter, and greener. From China's Belt and Road Initiative to Europe's green infrastructure plans, the message is clear. The future belongs to those who build it. America is re-entering this race with renewed vigor, determined not just to compete, but to lead. These projects are more than just steel and concrete. They are symbols of a nation's vision for itself. They are investments in our collective future, shaping how we'll live, work, and connect for generations to come. The scale is breathtaking, the challenges are immense, but the potential is limitless. This is the story of how America is building its tomorrow today. Behind every bridge, tunnel, and skyscraper, there is a human story. This is also true for the code that runs our world. Behind every app, every website, every algorithm, there is a digital story, written by thousands of programmers, designers, and data scientists who dedicate years, sometimes decades, to a single digital ecosystem. They are the unseen architects of our modern lives. They face immense pressure, the burnout from staring at screens for countless hours, and the constant uncertainty of a rapidly evolving technological landscape, all in the name of innovation. Every line of code written, every bug fixed, represents a moment of human ingenuity and perseverance. But it also reflects an invisible cost. There are the endless nights fueled by caffeine, the social events missed, the mental strain of solving complex logical puzzles under tight deadlines. Behind every piece of software we use, there is a silent army of developers keeping it running, updating it, securing it from threats we will never even know existed. They are the digital workforce, laboring in the ones and zeros that underpin our reality. Then there is the ever-present digital risk, the constant battle against a different kind of nature, the chaotic and often malicious nature of the internet itself. Malicious hackers, sophisticated cyber attacks, and unexpected system failures can undo years of work in a single moment. A zero-day vulnerability can bring down entire networks, exposing sensitive data and causing billions in damages. It is a relentless, asymmetrical warfare fought in the shadows of cyberspace. Because of this, software engineers are now designing with digital resilience in mind. They are building systems that anticipate failure, that can isolate threats and heal themselves. We see this in the architecture of modern cloud services. Distributed systems that can withstand the failure of entire data centers without the user ever noticing a disruption. We see it in the rise of chaos engineering, where companies like Netflix intentionally break their own systems in a controlled environment just to find weaknesses before attackers do. It is proactive defense. And in the world of cybersecurity, this resilience takes on a new form. Instead of just building firewalls, engineers are creating honeypots, decoy systems designed to attract and trap hackers, allowing security teams to study their methods in real time. They are developing AI-powered security systems that can detect and respond to novel threats faster than any human could. This is not just about building digital walls, it is about creating intelligent, adaptive immune systems for our digital world. It is survival programming. But software is not only technical, it is profoundly political. Every major digital platform, from social media networks to search engines, involves a complex web of interests. Corporations, governments, activist groups, and billions of individual users. Everyone wants the benefits of technology, but not everyone agrees on what those benefits should be or what the costs are. Debates over data privacy, censorship, and algorithmic bias can rage for years, shaping the very fabric of our online society. In some cases, the politics surrounding a piece of software become more complex than the code itself. Consider the battle over encryption. Law enforcement agencies demand backdoors to access encrypted communications for national security, while privacy advocates and tech companies argue that any backdoor for the good guys will inevitably be exploited by the bad guys, undermining the security of everyone. This is not a technical problem with a simple solution. It is a fundamental conflict of values. Similarly, the regulation of artificial intelligence is becoming a global political battleground. Who is liable when a self-driving car crashes? Should AI be used for autonomous weapons? These questions cannot be answered with code. They are ethical and political dilemmas that society must confront. The decisions made in legislative chambers are now just as important as the decisions made by programmers. This tension between technology and society is not new, but the scale and speed of digital change have made it one of the defining challenges of our time. The stories of the people behind the code are often lost in the whirlwind of progress. We celebrate the founders and the CEOs, the public faces of tech empires, but we rarely hear about the legions of programmers who brought their visions to life, the ones who solved the impossible problems and worked through the night to meet a launch deadline. Think of the engineers who built the software for the Apollo moon landing. Their code was woven by hand, a marvel of precision and ingenuity. A single mistake could have been catastrophic. Their story is one of incredible pressure and responsibility, a testament to human focus and collaboration. Or consider the open source movement, a global community of developers who volunteer their time to build and maintain software for free, for everyone. This is not a corporate project. It is a collective act of creation, a digital public good built on passion and a shared belief in the power of collaboration. It is a story of community, not commerce. The challenges they face are unique. Unlike a bridge, which is built and then largely stands static, software is in a constant state of flux. It must be maintained, updated, and patched. Yesterday's revolutionary code is today's legacy system, a tangled mess that new programmers must carefully navigate. This creates a kind of digital archaeology, where developers must dig through layers of old code, written by people they have never met, to understand how a system works and how to fix it without breaking something else. The pressure to innovate is relentless, but so is the burden of maintaining the past. And as our world becomes more interconnected, the stakes get higher. The software that runs our power grids, our financial markets, and our healthcare systems is now critical infrastructure. A bug in a banking system can cause financial panic. A vulnerability in a hospital's network can put lives at risk. The programmers who work on these systems carry a weight that is hard to comprehend. Their work is a high-wire act, where the consequences of failure are no longer just a crashed app, but a potential societal crisis. This is the hidden world of software development. It is a story of human creativity and fallibility, of collaboration and conflict, of relentless innovation and the heavy burden of the past. It is a story of people who are building our future, one line of code at a time, often in complete anonymity. They are the architects of the invisible, the engineers of the digital age. So the next time you use your phone, stream a movie, or connect with a friend online, take a moment to think about the invisible world behind the screen. Think of the silent army of developers, the digital resilience they are building, and the complex political battles they navigate. Their work is not just about technology, it is about building the society of tomorrow. Just like the engineers who build our physical world, they are shaping our reality, facing immense challenges and leaving a legacy that will endure for generations. Behind every digital interaction, there is a human story. America's $500 billion pipeline isn't just a list of projects. It's a test of engineering, of leadership, and of our ability to build a future worth living in. So, that's a look at America's megaproject pipeline, a world of ambition, engineering, risk, and reward. If you're fascinated by how the world is built, and how it's about to change, you're in the right place. The stakes have never been higher, and the world is watching. Thank you so much for joining us on this deep dive into the world of megaprojects. If you found this interesting, don't forget to hit that like button, subscribe to EngiArchis, and ring the bell so you never miss an update. We'd love to hear your thoughts in the comments below. Which of these projects are you most excited about? Until next time, keep exploring the world around you.